hit the record this meeting button and start recording for the day. So today we are going to be talking about, let me pull up my fancy PowerPoint and start sharing my screen. I got this. Nobody panic. Okay, Lighting and Building Systems, Session 2. So lecture is going to be, oh, I hear a little bit of reverb in the background. Everyone muted? Yes? Okay. The lecture is going to be mostly on the introduction to building codes and navigating the code, building uses and occupancy. I've actually moved that a little bit to the end, although it's relevant to the whole day. I'm going to start with some of what the book covers and little pieces of information outside of the book that I found to be interesting and add to our learning on a little bit of the building envelope, sustainability. We do have in our reading for this week available to you the LEED Chapter 2 that should be read in tandem with Chapter 2 in Building Systems for Interior Designers. I will open the LEED chapter and pick out a few pieces for you to pay close attention to as you're reading this week. On top of the building envelope, we'll also be talking about designing building functions for health and human safety, which a lot of you talked about, and the importance of the code last week in your discussion board. Thermal qualities in building, and a little bit of Hammurabi's code leading into finally the building codes illustrated. Okay, so before I get started, I looked at the quizzes. They really weren't that bad, all things considered, that the quiz was testing to the second edition. I have my book that will be arriving early next week. If I found that there were a couple of questions that across the board people got wrong except for one or two people, so I might get rid of one of those, but overall I think I'll keep the questions and use it as an evaluative tool and possibly give some extra credit we were talking about for people who got the question wrong that I was taking away maybe. So it's not going to count as a normal quiz eventually. I'll have to decide in the third week once the real book gets here and I have time to look at how close the two were, just how I want to handle that. So design building functions for health and human safety. The building envelope is the transition between the outdoors and the interior of the building, consisting of windows, doors, floors, walls, and roofs. The envelope encloses and shelters the space and protects it against sun, rain, and wind, and harsh temperatures. Entries are the transition zone between the building's interior and the outside world. So here's a picture of the building envelope. It's kind of showing us the different places that we have to take into consideration, and it takes into account a lot of different things, including windows, doors, floors, walls, points of entry. Another definition that was given in your book on page 3 is the point at which the inside comes into contact with the outside, the place where energy, materials, and living things pass in and out. The majority of time we're focused in on windows and doors when we're talking about the building envelope. The building's interwoven structural, mechanical, electrical, plumbing, and other systems create an interior environment that supports our needs and activities in combination with thinking of how the building envelope interacts with the indoors and the outdoors. Page 16 in the book says the envelope is sensitively attuned to the resources of the site, the sun, the wind, and water. The boundary is manipulated to balance the energy flowing between the inside and the outside. And they do talk about the number of ways in which we can do that, whether it's site location or the sizes of windows, possibly the tinting in larger structures such as skyscrapers. They end up talking about curtain walls and how the development of those highly impacted the ability to build taller. So moving forward, I really want to get to what your homework's based off of. So design building functions for health and human safety continued thermal considerations. So when we're talking about thermal consideration, a little bit of information outside of the book, I found that the architect has to consider a number of things. So support for proper thermal and lighting conditions in the building form and in the structure. So in order to provide a thermal and ventilation comfort, and at the minimum, the expectation would be they'd comply with the American Society of Heating, Refrigeration, Air Conditioning Engineers, so that's called ASHRAE, ASHRAE. You will not be tested on that. And it's not something that's going to come up necessarily in your book, but it's one way in which there's a control on some of these contract buildings. ASHRAE, the acronym, will control the thermal ventilation comfort by having codes that pertain to the heating, refrigeration, and air conditioning. Okay, so thermal environmental conditions for human occupancy. It's important that they incorporate natural ventilation if appropriate to the location and consider adjusting the requirements of ASHRAE to account for impact, analyze room configuration and HVAC distribution layouts to ensure all parts of the room are receiving adequate ventilation, especially places where teams or groups meet. Consider providing individual environmental controls in these rooms. Analyze placement, configuration, and types of windows of skylights as provided. Also provide adequate controlling shade activity to avoid hot spots. So that could be window treatments, or as I said, it could be tinting to prevent the issues of hot spots that are caused by direct sunlight. Consider providing a temperature and humidity monitoring system to ensure an optimal thermal comfort performance. Evaluate the use of access floors with displacement ventilation for flexibility, personal comfort control, and energy savings. Provide individual air and temperature controls at each workstation. So that's getting fairly specific. In contract office design, that would be very expensive to do, to provide those individual controls, although I've seen it done by sections or quads within an environment for the office where we have up to 8 people working in a cubicle, and then within that 8-person grouping, they do have their own personal controls. I think controls for each of the areas within a building is something that's seriously lacking in the majority of large contract offices, especially locally. Provide individual air and temperature controls that utilize CO2 sensors to assess the air quality of spaces to adjust ventilation. Thermal mass is another important characteristic that affects thermal performance of construction. So thermal mass is different depending on location. So heavy walls, roofs, and floors have more thermal mass than light ones. Thermal mass both delays and dampens heat transfer. The time lag between peak outdoor temperature and interior heat is different. So in the desert, they have a different thermal mass to their buildings than we have in, say, places like the Midwest. So they actually have added layers of concrete to increase their thermal mass so that it stays cooler. So those are some extra things on thermal controlling. So design building functions for health and human safety continued. Here's just an example of all the different forces that should be taken into consideration. So we have internal phenomena, occupancy and use, HVAC system, lighting, machinery, equipment, building materials, finishes, inorganic agents, and organic agents. I don't think people realize just how much occupancy and use can have an effect on a building, especially the heating of a building. And certain rooms can heat up faster depending on how quickly they're filling up with people. We have on the outside external phenomenon like climate, gravity, weather. A lot of times they'll talk about snow stacking on roofs and how that affects a building and how we have to build and plan for that. We have also inorganic agents from the exterior and organic agents such as wind and water, some inorganic. We might even have some radiation. We also have site conditions, so humidity and possible gradations in the ground and seismic forces, earthquakes, things that we have to consider when building, picking materials, and choosing their occupancy and uses. So over here, I've provided a table that shows some requirements such as structural strength, rigidity, control of heat flow, control of airflow, control of moisture flow, control of solar radiation, control of sound transmission, control of fire, durability, security, economy, all of these things, and even aesthetics. I like how aesthetics is crushed down there at the very end. So this is when we're talking about sustainability and the thermal requirements and what the changes have become in building systems for interior designers. I'm going to go ahead and go to the source that I'm referencing, which is number 1 here, and if you go to the end of the PowerPoint, way at the very end, dun, 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 here's where you can find the sources. I have it open in the background actually, so I'm just going to minimize it and go out to it physically. And I want to go back one from here because I got ahead of myself. So building enclosure, design principles, and strategies. This was a very useful resource of the National Institute of Building Sciences. They lay out in a clean way with scientific support to the side different topics such as the one that we're on right now, and the other one I thought these two are the most important that you could review in your own time or in tandem with your reading from this week: Building Materials and Furnishings Sustainability Assessment Standards. That both of these layouts for those information were helpful, and they had a lot of visuals to go along with the information. So I'm going to take the time to read through a portion of this, keeping in mind trying not to read over, not go more than 7 minutes probably on this. So the innovative design building enclosure relies less on successful past presidents than the application of building science. This is not because there's little to be learned from existing buildings, but is due to the changes in materials and methods that result from building technology innovation. Combined with growing expectations for high performance, building enclosure design is now required to satisfy a large number of performance parameters that were not given a great deal of consideration in the past. Building enclosures were always expected to be durable and provide a degree of environmental separation, but now they must address issues like energy efficiency, daylighting, indoor air quality, fire safety, thermal comfort, and a carbon footprint. There is now a need to explicitly ensure these performance of objectives are fully satisfied at the design stage. So that's as much as I'll read from the introduction. It gives you an idea, though, that it's talking about all the similar information from the book, just laying it out in a different way. So if we scroll down, I like the description, the principles of enclosure design. So the requirements for wall performance were outlined some half-century ago and are applicable to the enclosure systems and components. The major considerations were strength and rigidity, control of heat flow, control of airflow, water vapor flow, liquid water movement, stability and durability of materials, fire, aesthetic considerations, and cost. So here's where they put that table for the performance requirements of building enclosures and their corresponding assessments. So they're checking if the wall meets the parameters. Is it load-bearing, non-load-bearing, wind loading, seismic loading, thermal effects, the stack of a wind pressure, HVAC influences. So all of these things that we're taking into account when we're starting at the very beginning of the design process. And especially more so if we are trying to get our building LEED certified. They'll have a team that's working together from the beginning to evaluate these things more thoroughly than we might if we started more with an architect and general contractor who are concerned about filling a certain site rather than sticking with the LEED requirements. So then I found it was interesting. Here you can see the physical phenomenon diagram that I showed earlier, and it has a better description. If we had more time, I'd read it for you. But it broke down in climate and zone some of our regions. Now the book said that Indiana was not considered cold. And then I think it's a valid point from those of you who got it correct that if you were to take the longitude and latitude and then follow the book's instructions of how to find if it was either a temperate climate or if it was cold, you would indeed have found that Indiana is not considered cold. But the book is old, and I think it's kind of more of a split rather than one true answer to that question, so I'll be thinking on that one. I just thought this was a clearer breakdown of the individual areas as opposed to cutting it into a nice dichotomy of cold or temperate. So here we have very hot, hot, warm mix, cool, cold, very cold, and subarctic. So Indiana is not too bad in the grand scheme of things. We're not subarctic, so we're doing pretty good. But all of those things are considered, and they have different materials that would apply to those areas. Humidity is a big one, especially when it comes to flooring, which I'll talk about here in a minute. Then here's a precipitation exposure graph, which is something that wasn't included in the book that I think is also interesting to look at. And I think it's interesting that this one, we see the horizontal axis in a fairly clean break as it goes down from top to bottom, but this one turns into more of a vertical dynamic. And so it's interesting how precipitation is different than the actual climate. Completely different in how it appears on the map. All right, we have things on heat loss, and these are all things I couldn't give to you, but as you're working towards your final project, which is way down the line, it's not going to start today. We have plenty of homework assignments before that. So this would be a good resource to go back to, and it gives you some ideas of things to think about for your site and your building as it pertains to conserving energy. And it's making your employees and workers comfortable within the environment, taking into account external and internal forces. They do a great job. Tons of wonderful pictures. As designers, we all love those visuals. Okay, so without talking too much more on that, I also found it interesting, and let me go back to my PowerPoint, not get too far ahead with my favorite websites. I'll go back to where we left off. So we just covered this. Let's talk a little bit about the plenum. So the plenum is the space between the ceiling and the floor above where mechanicals are located. In commercial spaces, sometimes the return air will run freely through the plenum, whereas the supply air will run through the ductwork. If the air circulates freely through an open plenum, code restrictions will limit the location open areas. What type of wiring can be located within restricts combustible materials. Equipment will often continue vertically down a structurally created shaft called a chase. All right, so you can see my notes below there because I didn't maximize this for you. Let's maximize it. Plenum. Okay. So on page 20 in the book is where you're going to find this diagram, which is blurry, of the plenum. I guess it's this there as a reference for you. I wanted to talk about, in the book, they have a little blurby to the side where they say, as an interior designer, you'll be responsible for locating the lighting as it pertains to the issues with the plenum. That's actually very true if you're going to go into contract design. So you might think, I'm never going to have to deal with this. And when I teach AutoCAD class, I try to put into perspective for you what work is actually done by an interior designer. Now, sometimes this is where I like to break it down into. There's an environmental designer who is more concerned with finishes and furniture. And yes, initially you might be diagramming out the lighting, but eventually you're going to pass that on to a lighting engineer. So we can aesthetically say, here's how we'd like it to look. But oftentimes we're just making a suggestion as the person who has the eye towards design, and then we're handing it off to a lighting engineer who actually knows the foot candles, how the logistics of the lighting would work, what type of bulbs would work best with how much electrical they have available to them in that building. But here's my personal experience. So I was asked to design, and I showed you a little bit in the About Me week, a chandelier for a company in a stairwell. And we started with the contractor with a budget that was really big as he estimated the cost. And so we were going to put a chandelier in the center. We were going to do LED lights on the side. I was supposed to take into consideration that the building was built in the 60s and it had mostly incandescent lighting, but they wanted to start conserving energy. So they asked me, what do you think? Is it going to be an awkward transition if we don't get rid of the hundreds to thousands of other incandescent lighting outside of the stairwell, because there'll be that kind of more of a bluer light, or you'll notice the transition. Should we change them all out, or is there a special LED light? So I did some research into the outer casing of what I wanted it to look like, and then I talked with a lighting engineer about what kind of bulbs were available for those lights and what type of light level and color of warmth was available. And then he did a schematic for me. Well, the lighting engineer and I came up with a plan, and it was supposed to be implemented. Then the contractor who was doing the demolition got into the ceiling and found that it wasn't as cut and dry as we thought. There were pipes from the plenum above in the building, which happens to be a hotel/office building, that were preventing those casings to fit by literally a quarter of an inch. So we bought the light fixtures, but then they never went in and physically measured the width of the casing, and all me and the lighting engineer had taken into account was the face of the light. So it became a huge ordeal, but I mean, eventually it ended up being beautiful. There's just a lot of people who are involved in the project. Most of the time, we will be asked to make an aesthetic decision, and then they'll go in and check it, the contractor and the lighting engineer, and they'll tell us what is possible, and then we'll redo our aesthetic design based off of that. So I don't try to get too wrapped up in all of this, but I do think we're responsible for saying how many lights we'd like to see, and then they'll say, oh, that's too bright, and then we'll taper it back to aesthetically what's pleasing. Let's see, going forward, so plenum, that does happen. That's kind of as much as they talked about it in the book, not a ton more. In a multi-story building, the stairs, elevators, restrooms, and supply janitorial closets are grouped together in a service core. The location of these mechanicals and services vary little, if any, from floor to floor. So that is one of the smaller statements in the book that has one of the most important meanings to you as a student in this program. It just touches on it briefly. It gives you these two diagrams. I'm going to expand on it a little bit tonight. The service core is one of the most important parts of any contract building. And when you go into jury and you get into either contract design or just advanced interior design, you're going to need to consider that first thing, especially if you have multiple levels. A lot of times students will turn into me a drawing where the first floor has, let's say, elevators at the center here, and then a stairwell and some restrooms. But then when I get up to their second floor, they might have the elevator still here, but they put the restrooms over here. That's just not the reality of how buildings of this size work. We're trying to keep as much of the supply janitorial, elevators, restrooms grouped together and in the same location throughout the entire building. One, because plumbing is really expensive to move and modify. So if it's not existing in a location and you're adding or remodeling on a second floor, it would be hundreds to millions, $100,000 to $1 million of cost to add it in those corners as opposed to the center, or vice versa if it started on the first floor on the outside. But at the end of the day, there's reasons to why you'd either have it in the center or on the outside, and they talk about that in the book. It's just the biggest mistake I see students make when they move into contract from residential is to break up the service core and put it dispersed throughout the building. All right, we can also help to increase the privacy by keeping it together, as opposed to when we start breaking the restrooms out and they become part of our more public areas. So there's a whole design philosophy that goes into keeping these items together. And I'm going to pull up some background information outside of the book for you to review and consider. So I'm going to escape out of my PowerPoint for a second and talk specifically about the historical evolution of the Service Corps. Okay, so this was a great article that I found on the Council of Tall Buildings and Urban Habitat. It's a research paper, not by a student, by a practicing architect. So he talks about the Service Corps, and I will briefly read pieces and parts of this because I think it's that important. So the Service Corps is a distinctive feature of a tall building, and its design plays an important role in the success of the sustainability of the whole structure. The Service Corps is a distinctive feature of a tall building. It provides the skyscraper with the structural solidity, room for elevators, toilets, and other amenities, and constitutes the main network of utility services, power, and data. Though many of these elements were present, even the very first example of this building typology, the actual Service Corps is the result of an evolutionary design process that has taken more than 100 years and is still evolving. The present paper examines the designs of early skyscrapers in Chicago and Manhattan through zoning restrictions and technological innovations of post-World War II period. To present modern control procedures of elevators, the role of the Service Corps has always influenced many aspects of the whole design of tall buildings concerning the structural system, the access and egress strategies, and sometimes even their shape. The future trends for the evolution of the Service Corps are mentioned, including the innovative design strategies adopted in some recent skyscrapers. So this will be the most interesting part of the article. I'm going to probably read the first pieces of it, skip the middle pieces, and then get to the innovative design strategies adopted in some recent skyscrapers, and even show you a physical example with the Fauché, which he talks about here. It's a building in Minneapolis, Minnesota. So I'm going to pick out some pieces. He basically takes this first part to talk about the early years of the tall building, how they were developing skyscrapers, how they started talking about zoning, and people were picking their plots of land without very much of an eye to the sustainability or even to the envelope of the building. Not very many considerations in building materials, and then it starts getting into how it became stricter. And even it says that the role of the elevator was so much important that the first descriptions of such new typology refer to them as elevator building or elevator architecture as it pertains to skyscrapers. Despite the common ingredients, it must be emphasized how the initial evolution of the tall building typology led to the distinction two completely different organizational schemes, a slender tower and quarter blocks linked to historical and urban characteristics of two cities, New York and Chicago, where they developed. So he gives a few pictures of how they grouped their cores. So here we see a core that's found at the center. And here we see a core that's found at the edge of the building. He talks about the differences and how some of them, like one city lends itself to having the core at the center, and then the other, where they built it on the outside, they were often planning to connect the building at a later time. So if any of you were in my history class today and we're talking about courtyards in ancient China, it's kind of the idea, except instead of in here it's a service court instead of a garden connecting the two buildings, and then just mirroring it on the other side. And that way they were preparing themselves to have a central core with expansion. So if we read onward, it talks about further development and influences of the zoning laws. And then he gets into the modern Service Corps. So most of the stuff that concluded after he talks about the zoning laws was just talking about more transitions of the locations of the Corps. And some of it talks about how using exterior ladders for egress is kind of obsolete once you get past a certain height, and how instead they started to move to having the stairwells being more enclosed, having stronger wall structures around them, because there was just no better way than to put them at the center and keep them more protected, as opposed to having everybody exposed and egressing from the outside. So the modern service core, a proposed definition. After the multitude of towers built following the establishment of the zoning law, the evolution of the service core came to a halt. After a 50-year-long evolution that was concluded in the 1930s, the service core became defined as an element that gathers together the spaces necessary to provide visual, physical, and functional vertical connections that work effectively to distribute services through the whole building. So I like this definition a little bit better than just as it says it's a collection of the stairs and the pieces. I like the idea of the distribution of services, thinking how people need to get from one space to another within a building, especially in hospitality, let's say. A lot of times I'll see students who thought about the main egress for the overall people using the space, but they didn't think about service elevators. So an eye towards what we need to move in and out of that space from floor to floor. So skipping through the part that talks about the economy, let's see, it says such innovations together with the introductions of a glazed curtain wall, so we have a transition to better materials, the dependency between the form and building and service core. These innovations, along with modification to the building codes, for the creation of pure geometric forms that characterize skyscrapers built in the 1950s and were labeled the international style. So then he talks about the curtain wall, and I just have to summarize because we're going to run out of time to get the best part. So he talks about glass curtain walls and how that worked with energy conservation. And then he goes on to talk about today a new idea of the service core and an evolution still in process. So in the last few years, a new wave of innovations to the service core design has been related to sustainability issues. The promoter of these trends are different from traditional ones, who were formerly represented by final users, the industry, or the developers. The new key figures that are driving the innovations trend to be architects. In fact, it should be acknowledged that figures such as Ken Yang and Norman Foster, among many others, are in the forefront of the innovative development of tall building typology as a whole, and the service core in particular. Architects are reacting to the stimulus of sustainability more than the other players of the building process. The service core will then be credited an additional value of more functions going to be added to its elements. I think it's in your reading for the lead assignment tonight, which we're definitely not going to get to open up on screen, but the lead talks about how architects play a completely different role when we go from a traditional outline to building to when it becomes a LEED certified project and it's a non-traditional group of people working together with the common purpose of LEED. So architects are pretty much at the forefront trying to put together aesthetic, form, and function. The future trends in development will mainly be focused on displacing the service core from its traditional central position in the building plan. Peripheral or external service cores moved to the sunny side of the building will moreover be used for shading the occupied spaces. Early examples of this trend are to be found in the Soames Inland Steel and One Bush buildings located in Chicago and San Francisco respectively. Both were built in the 1950s. So he talks about more examples of the core and how when the core moves to the outside, it says an external service core can provide valuable option in those climates where natural ventilation is viable. And then he talks about more benefits. He'll talk about energy, letting air in, keeping light on the entire exterior of the building. But what he's really showing is we had them at the center, we've had them kind of on the corners but still maintained within the building, and now he's talking about having a completely exterior to the whole building concept service core that's its own offshoot of the building. So this is where he sees service cores going, and he sees it because it's more sustainable, which he ends up explaining. An evolution still in progress. So I can't spend much more time. Very interesting read, and as you progress in the program, articles like these, we don't just want to be thinking about our books. Not that our books are completely obsolete, but they tell us about what we're used to. I think more important for your focus in college should be, where are we going? And asking those hard questions about who is projecting the best idea of where we're going, and coming up with your own ideas about where we should be going based on sustainability and green building. Okay, so this is a good read. I also reference this for you in the PowerPoint, which I will post. It's number 2, and you'll find it at the end of the PowerPoint. So now getting towards your homework with the remaining time. Let's go to the building codes and how we use the International Building Code. So Tan posted for me in your first Blackboard session of conversation a little bit about Hammurabi's Code of Laws and how that comes into the very basis of the building codes. So it reads, if a builder built a house for someone and does not construct it properly, and the house which he built falls in and kills its owner, then the builder shall be put to death. If it kills the son of the owner, the son of the builder will be put to death. If it killed the slave of an owner, then he shall pay the slave for the slave to the owner of the house. If it ruins goods, he shall make compensation for all that has been ruined, inasmuch as he did not construct it properly, this house which he built fell, and he shall re-erect the house from his own means. If the builder builds a house for someone, even though he has not yet completed it, if then the walls seem toppling, the builder must make the walls solid from his own means. So we see some form of accountability that Hammurabi had an eye for the future of just how important it was that we build safe structures. And it really affects people's lives. It's a life or death situation. It's that important. International Building Code. So this was a book that in the first session I said is available to you through the Ivy Tech library, and then showed you how you could sign up for that. Here's the link to get started on that. You would just go to the site here and then type in building codes, and if you haven't already, sign in and create a login, which will get sent to your email. The International Building Code. Make this big and pretty. It's already big on my screen, but not big on everybody else's. The first edition of the International Building Code was published in 2000. Your book, I think, says 2002, but ignore that because the International Building Code says it was published in 2000. There's now a single national model code which is updated and maintained by the International Code Council, headquartered in Washington, D.C. Please note that some state and local jurisdictions make modifications to the codes in the use of their communities. It is imperative that the designer determines what local adoptions and amendments have been made to be certain what codes apply to a specific project. Usually the contractor, the architect, they'll all have a copy of the most up-to-date codes for your state and local jurisdiction when they're working on a project, and they can give you a copy. There are also specific federal requirements that must be considered in design and construction, in addition to locally adopted version of model codes. Among these are the Americans with Disabilities Act 1990 and the Federal Fair Housing Act of 1988. We will always comply with the strictest codes governing the local jurisdiction, whether it be federal, state, or local. Get pumped up. We're going for it. Okay, so using the code, you're going to find this diagram in navigating the code in your book. So the following procedure is recommended as being helpful for using the International Building Code. Note that most of the major issues are interactive, and that iteration of relationships will be required to optimize design solutions. The procedure can be paraphrased as follows. Classify the building according to occupancy type, construction, location on property, floor area, height, and number of stories. For your homework, we'll be doing classifications of occupancy, local occupancies to us, but if they're not local to some of you in another area, you'll still be able to Google and look up the location we're talking about and then figure the occupancy based off of your building codes chapters, which I've provided to you on Blackboard for the week. So even if you don't have access to the building codes or are still confused how to get there, without going over it again, they are scanned in for you for this week's assignment. Occupancy classification is the first, then sprinkler systems, type of construction, allowable floor area, height and numbers of stories, location on property, and means of egress. Means of egress is going to be the most complicated thing that you are going to undertake in this class, I'd say. Sprinkler systems, while it's important for our reflected ceiling plan, I feel is still a little bit more straightforward than when we get into means of egress. So let's focus on occupancy and classification because we've got enough weeks left in this class. We don't have to focus on the rest of that chart. So sustainable buildings, green building, and efficiency. I just wanted to cut through some of this before I go back into the building codes part. This was the summation of what was important from your lead reading, but still read it. Close to transportation and low emissions. I just wanted to underline this for you guys. The close to transportation and low emissions part, that often gets left out in the final project and is in one of the easiest ways to tell me that your building is supporting the LEED and green building design. So by telling me or coming up with a fictitious location of your building and how close there is public transport to lower those emissions. Mechanical building systems, lighting are the other things that you take into consideration that was covered in all of those articles as well as your books. And then environmental benefits are outlined, so economic benefits, health and community, and conventional versus integrated. It talks about how I said the architect's involvement, the designer's involvement, how that changes from conventional, which is, or a traditional version of how we run a project without LEED, and integrated where LEED is put into the project, and completely different, even a more creative version of running a project. All right, so now we're really doing the building codes. So let me show for you for your homework. Here are the occupancies that you'll be using in your homework. We break down building occupancies as assembly, business, educational, factory and industrial, high hazard, institutional, mercantile, residential, storage, utility, and miscellaneous. All this information is more outlined and expanded upon in your reading this week. So I'm going to go to class sessions and click on Session 2, Design Building Functions for Human Health and Safety, and then I'm going to go into required reading. So here's your LEED Chapter 2. Please read this for this week. Building Systems Chapter 2. This is, of course, the second edition. If you have the third, go ahead and treat it like last week where there's less emphasis on the quizzes. I'll be weighting the homework more heavily, possibly. And then lecture is where I'll eventually make this live. It'll just be my PowerPoint with the sourcing in case you want to read through some of that. And then Building Codes Chapter 1 and 2. Let me click on Chapter 1. So it was a little hazy. The scanner didn't do the best job for me, but it talks about why the building codes exist, and it reiterates Hammurabi's part in that. And here we have the protection of health, safety, welfare, and public is the basis licensure for design professionals and the reason that building regulations exist. A little bit of an outline. The International Building Code, continued. Okay, so a big one that you'd want to focus on in reading is the Americans with Disabilities Act and the Federal Fair Housing Act. Here it talks about the difference between state and local building codes, other codes, and code interactions. It'll talk about things like what to do if you have a multi-use facility. So you're saying there's a theater in here, there's also a bowling alley, and then I have an atrium. It always says that you pick the biggest area of the building or the one that most encompasses the building to define it as that. And a lot of times you'll have to go through an approval with a multi-use facility anyway, but when you're turning it in and are first recommending the occupancy you're claiming the building has, you would go towards the biggest of the three options within that building. standard care, life, safety, property, performance, prescriptive codes. All of these things to give you a good background on why we do this and what it's helping us to achieve. But for your homework, we're going to read one, not only one, but also two. Navigating the code. The key word to remember about how building codes are developed and how they work is intent. So this is kind of saying you're going to get into an area where you're saying, well, I think I'm reading the code one way. It could be applied another way. There are gray areas or ways in which you could bend the code if you get approval on it and say, well, I am having two different multi-use facilities. This one is smaller, but this is the one that's going to have the higher occupancy. That's allowed due to the building materials of it. There's some where they overlap in different ways that you're going to have to think of the intent behind the code and how it applies to what you're specifically doing. So do not try to ignore the code, do not try and confuse or obfuscate code issues to achieve approvals. Don't try to trick the code people as you turn them in for approval. Intent and interpretation continued. They're going to kind of put a diagram here to talk about what could possibly be meant by intent and how you could interpret something differently than it actually intends to be interpreted. They're very good. I mean, there's not very many books that tell you how to read the book before it starts. So you're going to get into it knee deep and be concerned, go back and read these chapters. So that's all how to navigate the code. But then, separate from that, extra info, Chapter 3, Occupancy. This is the one that's going with your homework. So reading assignments that the quiz will be based off of are going to be LEAD Chapter 2, Building Systems Chapter 2. Then code information, this is more how to use the building code book. And then the extra Chapter 3 in here. Let me organize information for you. Okay, so let's put the code together and maybe put it under here even. There. So that's where it was. Okay, there, that's where I wanted it. So the Chapter 3 to be closer under here. So Chapter 3 is going to go with your homework. So Chapter 3 with your homework. This is going to be with your quiz. And these are kind of with your homework, but they're more if you get into this part and think, man, I don't know what I'm doing. I should kind of refer back to how to read the book. But of all the things that are easiest, I would say use and occupancy classifications is it. So it's going to be fairly self-explanatory. We're looking at assembly, which was Group A. It tells you what assembly Group A is. It's an occupancy that includes, among others, the use of a building or structure, a portion thereof of gathering of persons and purposes, such as civic, social, religious functions, recreation, food or drink consumption, or awaiting transportation. So Group A breaks into some subgrouping, which is different. Some of them only have A, B's, there's A, B, C, D. Some might just be B and it covers everything. But A breaks into A1, A2, A3, A4. So A1 is assembly uses, usually with fixed seating intended for the production and viewing of performing arts or motion pictures, including but not limited to motion pictures, symphony, television and radio, and theaters. Assembly A2 uses intended food and or drink consumption, including but not limited to banquet halls, nightclubs, restaurants, taverns, and bars. A3 uses intended for worship, recreation, or amusement, and other assembly uses not classified elsewhere in Group A, including but not limited to amusement, art galleries, bowling alleys, places of religious worship, community halls, courtrooms, dance halls, exhibition halls, funeral parlors, gymnasiums, indoor swimming, lecture halls, so on. So they're fairly clear, right? We can see the subdivisions. You might have some overlap as opposed to the food consumption eventually with restaurants and other places like bowling alleys that might serve food, but really we're focused on the main purposes of those buildings. So it's not like if there's a cafe in a bowling alley, then it's going to have any need to put down that it's A3, A2. We just say it's A3 because its primary purpose is a bowling alley. You continue on, it'll show all the different types of groupings. So we said business, educational, factory, high hazard, and high hazard is always an interesting read. So it talks about boiling and combustible dust and combustible fires, corrosive control areas. So it gets pretty crazy. All the rules that go with things like power plants and aerosol product. But again, very straightforward. You won't even end up using any of this chart information at the end. You'll just be able to stick with the occupancies as they're laid out, with their descriptions, and then they give you great examples. So going back into this week, if we look at your homework, so we're under reading right now. If we go back under class session 2, homework and assignments and quizzes, here we have your discussion board. So list 5 buildings that you frequent and determine the occupancy classification using the Building Codes Illustrated book. Respond to 2 other threads discussing the classification of their selections. All posts due Wednesday at 5 p.m. Session 2 assignment. EDSN 200 lighting assignment. We'll simply click on it. It should download and then we can open it. So it's worth 100 points. And what I need you to do is tell me which occupancies those are based off of what we just covered in the building codes. So chapter 3 of the building codes book. And then you're just going to say, oh, it's a bowling alley. If I go back and look at my building codes chapter, that would tell me it's a 2, okay? Which might not be. It's either A2 or A3, I believe. But Crowe Chiswick, a CPA firm, so accountants, what would that be? Bob Evans, Memorial Hospital, Macy's, and some of them, even though you're not super familiar, I mean, all you need is hospital. Who cares? It's Memorial. That should be enough information for you to deduce the occupancy. BW3, so that's a restaurant. Studio B Architects. The Marriott is a hotel. Stanley Clark School, Crazy Steve's Fireworks, that'll be a fun one. But you can guess what that one is. Madison Center, La Petita Academy, it's a school locally as well. The Icebox. Now, there's also different sizes, as it talked about in occupancy, and that might change it from an A such and such to an A such and such else. But think about main function, Performing Arts Center. Morris Performing Arts Center has some other things going on in it as well. You might have to do a little bit of research on the places. We're into the real homework assignments, done with the days of pure discussion board. Let me go ahead and check at the chat. Unforgivable, Nicole. I can't believe you just got here at 7:38. Okay, so other than that, are there any questions on the homework, the quizzes, or the reading? You can type it in the chat or you can go ahead and speak because I don't have any of you muted. So if we go back, I just had a question. This is due on Wednesday too. The homework functioning part. Let's see. Session 2. I believe that's what I have it set to be. That's what I was going to say. If we go back to the announcements, I had decidedly made it lighting and building would be due dates, exercises, so that's assignments, Wednesday at 5, discussions Wednesday at 5, and quizzes could go into Thursday. So you would have time to get your quizzes done. And then it also forces you to break up your homework instead of trying to put it all on one day, which is good time management actually, unless you only have Wednesday in your schedule to do it. But those are the due dates of everything that remains in the class, except for the final will be structured differently, and then one of our larger tests would be structured differently. So let me go back to the class session and see if there's anything extra that you can use as a source in session 2. I might delete required reading, a duplicate information that I saw. So we have building codes 1 and 2, and then building codes chapter 3. I can delete this one. Okay. Okay, so then I have 1, 2, 3 of the chapters, lead and building systems associated with quizzes, and then 1, 2, and 3 will help you with your homework assignment. Continued netiquette you guys did fine in your initial discussion, so I'm not too concerned with that. And then session 2 lecture. So I'm going to go ahead and upload my lecture for you now. So I'll edit this and delete the old ones. Mark for removal. EDSN session 2. Close. Save it. And I'll browse and attach it. So desktop, downloads, EDSN session 2, PowerPoint. Okay, so now it's updated to be my PowerPoint with the extra information and even the notes, which I'm fine with. You'll just have to look at it in the normal PowerPoint format. And then if I go back, quizzes you should be fine to do, the required reading. I know there's a piece that was missing, so let me just open up my PowerPoint one more time. Okay, so this was just a clear diagram of the different group assemblies. A and B are almost the answer to everything. Now, for the initial homework assignment, there's going to be a few crazy Steves that are thrown in there so that we can get some variety, but A and B are the majority of what you will work with in your future careers. So Group A assembly and then Group B business. Make it big. There you go. So A1, assembly areas usually with fixed seats intended for viewing performances or movies, and some of these are a little bit different than what we actually read in the codes. They're kind of concise. A2, assembly where food and drink are consumed, includes gaming areas and casinos and commercial kitchens. A3, assembly areas that do not fit into other 2A categories such as worship, recreation, and amusement. A4, assembly areas for viewing indoor sporting events. A5, assembly areas for viewing outdoor sporting events. And then Group B business, there's office building, storage areas and file rooms, outpatient clinics, and higher education facilities. So make sure that when you're working on your homework, you're referring back to this diagram in tandem with your reading on the chapters on occupancy, because especially this A2 is a lot more concise about what we're looking for. And then there was another one, these two are a lot more concise. And then this is a good summation of these, especially outpatient clinics. Okay, so quiz 2, PowerPoint and handouts, occupancy classification, and building classification discussions. Does everybody have their books now, for the most part, besides me? The 3 edition? Okay, so Emily is still waiting on hers to be sent. Chrissy Foster says no. No. Well, we will work with what we've got. Caitlin Catanzarite is a yes. I do not yet. No. Caitlin Catanzarite, Liz is no. Do we have an estimated arrival of the books? That, are we thinking a week or 2 weeks more? Emily's ordered from a far off distant place that she didn't know. So hers says September 13th. Should be here by Saturday, within a week. Okay. All right. Well, I thought for what the quizzes were, it wasn't an awful majority of people who just completely bombed it. And I don't consider any like a 70 even close to bombing it as far as having a quiz that's different between two books. So there was one question considering tossing it out, that is Indiana cold? Because technically we saw tonight that it was, and the book would lead you to believe that it, or that it was not. Oh yeah, no, that it was, and the book would lead you to believe that it was not. All the other ones I felt could be found, except Nicole Catlett let me know that some of the lead information was not found in the third edition. So, Tom, you have a first edition? I have a lead book waiting on the other two. Or do you mean second edition? Is this for designing interiors or building systems? Oh, which one am I asking about? Um, More building systems, because building systems is what your quizzes will be based off of. Both the designing for interiors and the original book that I had said before I saw they changed it to designing interiors, the lighting for interior design, those books are supplemental kind of desk books that have visuals and more information on lighting, like foot candles and color and what lights to use in what locations. Those are more for your final project as references than they will be for testing material, although you'll still need them. So if you don't have the designing for interiors, eventually it's shared throughout multiple classes. The other one you won't need, the lighting, I guess they got rid of, so I'm going to post that as PDFs for you because it has way better visual examples. It takes a floor plan and a reflected ceiling plan, puts them side by side and shows how many lights would go into an office or how many lights would go into a residential living room, which is a lot more helpful to me than a bunch of text. I have the third edition building system quiz was totally different than what was in my book. I agree with Liz. Okay. So how'd you do so good, certain people? That's what I want to know. All right, so, okay, third edition. I should have it by Monday, and since the next class isn't by Thursday, I'll try and see if the school can get it to me and I can stop by and pick it up, and maybe we'll throw out or postpone. I say still just take the quiz for now. Don't, spend 3 hours trying to match information, and then I'll evaluate either having replacement quizzes for them or putting it towards extra credit for what we did get right. Might just be a bonus to you guys because of the school's fallback on this one. So I'm going to go ahead and release you. Thank you. I plan on running it mostly like this, so with supplemental material, because I don't like to just read straight out of the book. You all know how to read. I don't need to reread it for you. But I will give you sources to all the interesting articles, and they should be useful in completing your final as we get closer to it. Thank you, everybody. Have a good night. Liz, Caitlin. Yes, sir. Shemane, Christy, Brianne, Nicole. What? What?
That was insane.
The lecture or the homework?
Yeah, the lecture. The homework was insane too.
The thing is, I was 10 minutes shorted, and I think it felt longer because we had already been sitting here without being able to get up. Yeah, no break, and no food, and no drinks.